Welcome to our SPI lecture. So we have been discussing amplitude, power, and intensity. We've discussed amplitude, and we've said this is the difference between maximum value of acoustic variables and the baseline. It can be positive, it can be negative. And we also said that amplitude can be described using various acoustic variables like pressure, particle motion, density, and temperature with all their units. But remember, anytime we are comparing amplitude to amplitude, two variables in ratio, they are measured in decibels. So amplitude to amplitude measured in ratio, unit is decibel, power to power, the same decibels, intensity to intensity, we use the unit decibels. Now, with respect to sound and application of sound. So we'll move straight to power. Power in a sound wave is defined as the rate at which energy flow through the medium. So power is rate at which energy flow through medium. In other words, this is the work done within a particular distance or the work done during energy transfer. So in case of ultrasound, the work performed is the production of ultrasound wave by the transducer and the propagation of the wave through the tissue. So what is work again? Effort, distance cover, work is done. So in ultrasound, the work performed here is the production of sound wave by the ultrasound, its propagation through tissue. So ultrasound wave contain mechanical energy which vibrates molecule in the medium. Now the more the power, the stronger the vibration and the farther the sound will travel. The unit for the power is watt, milliwatt. A milliwatt is 1/1000th of a watt. Now the decibel may also be used to describe the relative acoustic power. That is the ratio between the two power. Now all electrical appliances and electronic systems have power ratings. They use power to work. For example, a toaster uses electric power and converts it into heat. A stereo amplifier uses electric power and converts it to sound energy into the speaker. An ultrasound transducer takes electric power and converts it into mechanical energy of sound. So the relationship between power with amplitude, power is proportional to the square of amplitude, and this is how they relate. Now if the amplitude is increased by a factor of 2, the power is increased by the square factor of 2. Power is increased by factor of 4. So many examples I could give you. Amplitude is increased by a factor of 3. The power definitely is going to be increased by the square factor of 3, which is 9. Same goes for if it's 4, square factor of 4 for power is going to be 16. So amplitude is proportional to the square factor of power. So make sure you know the relationship for your RDMS registration exam. It's very important. You don't miss this. You just have it in mind. Nobody's going to ask you to derive the formula, but you need to know how it relates. So power is related to intensity and area as follows. Power is equal to intensity times area. Intensity is measured in watts centimeter square. Area is measured in centimeter square. Intensity is defined as the concentration of power in an area. It is power in a beam divided by the cross section of that area. That is, intensity equals to power measured in watt over area, which is measured in centimeter square. The unit for intensity is watt over centimeter square, or milliwatts over centimeter square. Decibel units can also be used for intensity when we want to compare two intensities. From the above equation, we can see that power is proportional to intensity. Power is proportional to the square of amplitude. Intensity is proportional to the square of amplitude. So power is directly proportional to intensity. Thus, an increase in power will result in an increase in intensity. This is very key because some of your scanning machine has a button or a clickable button on the software where you can increase power or reduce power. It's very important you know how it works, how it came about, and the effect and impact it will have on your image optimization. So your increase in power by a factor of 3 will result in an increase in the intensity by a factor of 3 because they are directly proportional. Beam area also has a role. Area is the dominator of the equation. So there is an inverse relationship between beam area and intensity. If area decreases, intensity increases. And that is very true. If intensity decreases, definitely it will be decreasing on an increasing area. For a given power level, intensity is greatest when the beam area is smallest. Yeah, of course. The power is greatest at a particular point where the beam area is smallest. Now, this region is called the focal point. Thus, every ultrasound beam intensity is highest in the focal point. This understanding is important to avoid biological effect in body tissues. So, when you understand focal point and what is actually going on in the focal point has to do with intensity in a particular area. So you can now determine whether you want to widen your beam or you want to reduce your beam. When you are setting focal point, also understand the intensity at that point. But we are going somewhere so that it also occurs to you that there are also disadvantages of setting certain focal points. And when you do so, how long do you want to leave it there? So to summarize all this, intensity is directly proportional to power. Intensity is inversely proportional to area. Power is proportional to amplitude squared. Intensity is proportional to amplitude squared. Now, given a constant beam area, if power is doubled, intensity is doubled. That is, if the area remains the same, you increase power, you are increasing intensity at that point. If power increases by a factor of 4, intensity is increased by a factor of 4. Why? Because they are directly proportional. If power is increased by a factor of 5, intensity is increased by a factor of 5. If power is increased by 4%, just in case your machine measures in 4% in percentage, it's still the same thing. The most important thing is you understand the principle is basically direct proportionality. So if power is increased by 40%, intensity will increase by 40%. And so on. If you reduce power by a factor of 4, intensity will reduce by a factor of 4, and so on and so forth. But again, given a constant power, if the beam area is increased by a factor of 2, intensity is reduced by a factor of 2. That is, intensity is inversely proportional to the area. A wider area, lesser intensity. Lesser area, more intensity, and so on and so forth. So bioeffect. Let's look at bioeffect, power, and intensity. The power output of a transducer is an operator selectable control on most ultrasound systems. That means one can adjust it. Now, if you have that kind of machine, give that place an attention. Look for that. If you have a machine that does not have power, don't worry. There is an automatic adjustment that goes on within your system. But if you have it, give attention to it. The minimum output power needed to obtain an adequate image should be used because of a concern for potential adverse biological effect. Using the lowest available power setting on the machine will minimize ultrasound dose delivered to the patient. There's always an advice. You start from the lowest dose and you go up so that you minimize impact also while you try to optimize your image. There is no solid proof yet, however, that any damage can occur with image output of diagnostic ultrasound system. However, we have to be very prudent and cautious in our attitude towards any biological effect. The intensity is not uniform across the ultrasound beam and also not uniform throughout time, because in practice, the ultrasound beam is not uniform in shape, and we use pulse ultrasound, which have on time and off time. The beam area at any distance from the transducer face will depend on the crystal diameter, sound frequency, focusing. The beam is most intense, that is highest intensity in the focal point of the transducer, because this is where the beam, the diameter over beam area is smallest. This is also the area where the best lateral resolution of the transducer is found. That is where you have the best resolution. The image is clearer at the focal point. So where the beam is converging on, that's where the intensity will be greatest. Intensity will be greatest at that point. Example of acoustic power for 2 transducers. Now, if you have acoustic power of 2 transducers is 50 milliwatts. So transducer A, you have area of 2 centimeter square. Transducer B, 8 centimeter square. Intensity for A will be divided by 2 based on the relationship. Intensity for B will be 6.2 milliwatts per centimeter square. Now, transducer A has a tightly focused beam than transducer B. The beam area for transducer A is 2 centimeters square, giving a beam intensity of focal point of 25 milliwatts per centimeter square. Transducer B has a beam area of 8 centimeters, giving a beam intensity of only 6.2 milliwatts per square centimeter. So why should we know about intensity of ultrasound beam? The intensity of an ultrasound beam is an important consideration of biological effects on tissues. Experiments have found that biological effects of ultrasound are directly related to intensity and duration of exposure. So, I remember years ago, somebody, a a patient was concerned. He must have read something online with respect to this without having details of that information. He was talking about biological effects, affect. Now, what they don't understand is her argument was she has done scan more than twice in 2 months, and she was concerned that maybe the ultrasound is too much on her system. No, that is not what we mean by too much. The focus on a particular area for a duration of time is the concern, not the amount of time you come and go and for your examination. So intensity reading can be taken, which will indicate different exposure values to the patient. Intensity reading can be taken anywhere along the beam, but for standardization, the readings are done at transducer's face and at the smallest beam width. Transducer's face, what you get there is spatial average intensity, and the beam width calculation there is spatial peak intensity. So intensity can be measured in 6 different ways as follow. Whether you are measuring spatial peak intensity, which is the highest intensity at the focal point of the beam, or you are measuring spatial average intensity, which is the average intensity at the face of the transducer, or you are measuring temporal peak intensity, which is the highest intensity of the pulse when sound is on only. Remember, the ultrasound is an on and off mechanism. You on to send wave, off to listen, on to send, off to listen. So that's how it works. Then temporal average intensity is the average over time when the sound is on and off. It's a temporal average. Pulse average is the intensity average over the duration of pulse on time only, while maximum intensity is intensity averaged over the largest half cycle of the pulse. There are 4 parameter combination for intensity. You can wish to call it SATA, SAP, SPTA, SPTP. Now, all these combination is the combination of where we're coming from: SP, SA, TP, and TA, and so on. For SATA, is the average value of intensity average over on and off time. It is the lowest and or smallest intensity measured along the beam. SATP is the average spatial intensity averaged over on time of the pulse. Is the intensity of beam at the maximum point, average over time, both for on and off time. It is the truest representation of exposure by biological tissue, which we measure to study bioeffects. Now, when you're studying your ultrasound machine manual, you see these combinations. Now, those combinations are put there for you to understand that your machine is safe. They put all those values, but you should be paying attention to SPTA, because that is where your biological effect is measured. SPTP is the intensity of beam at its maximum point average on time. It is the highest intensity measured along the beam path. Now note, in continuous wave ultrasound, the TP and TA values are equal because it provides a continuous transmission of ultrasound energy. There is no pause or listening time. In other words, there's no on and off time. That's why they call it continuous wave. Your continuous wave is what you use for your fetal Doppler and other Doppler issues. And the easiest you can find is this one the midwives use to this electronic fetal